Hi friends, may peace and blessings be on you. This video is by the channel Physics Hunters. Hunt your physics related content in Physics Hunters. I would like to initiate with a quote. The spark of light in the soul is the beginning of self-awareness. If you realize what you are, who you are, you can success, you can achieve. So this is a general motivation that I can give before starting the class. So now the topic we are going to discuss about is refraction through convex lens. Hence we derive Lens-Maker formula. For that I have referred here the refraction at spherical surface, that is your convex spherical surface. So this is a general diagram that I have done in my previous video about refraction at spherical surface. Hope you remember this, right? So according to this idea, I have derived this relation N2 by V minus N1 by U is equal to N2 minus N1 by into 1 by R. So what is actually here, that convex spherical surface that I have considered a point object and two refracted rays and forms an image at I. So U is the object distance, V is the image distance. According to that, with respect to the refractive index N1 the rarer medium and N2 denser medium, I have derived the relation the N2 by V minus N1 by U is equal to N2 minus N1 into 1 by R. So now our aim is to go through about refraction through convex lens. So the lens is nothing but two refracting surfaces are bounded together. The way it is bounded will differentiate either it is a convex lens or concave lens. For convex lens, you generally have an idea that this is your convex lens. Am I right? So this is your convex lens where two refracting surfaces, that is bulged out. So both the surfaces are bulged out. This is termed as convex lens. Right? So for this condition we are going to discuss about the refraction. Hence we are going to derive the Lens-Maker formula. So here hope you have to go through everything about lens, convex lens, concave lens, its rules to form the ray diagram, to draw the ray diagram, and image formation by convex and concave. All these should be revised at this status. Already you would have done this in your class 10. Just revise it and come back to this derivation. So now our main aim is the refraction convex lens. For this, what is my general idea? First, you know that this is the first one that I have done, right? So this is the first refracting surface. The same side, the another refracting surface I have done here, right? So these two surfaces only together it is formed and form a convex lens. So the first refracting surface, this is the relation that I have already derived. Now my aim is to get the other relation for this refraction, that is your second refracting surface. So both of them are joined together and then it forms a convex lens, right? That is the idea. So now the second diagram will be like, say, the second refracting surface. This is the second refracting surface that I would like to show here, where this is your pole, and you know that a normal can be drawn from here passing through the center of curvature. And as you know very well, if you compare your previous diagram, this object distance is U and your image distance is V. This image distance V, now I am going to take it as V1, since for two refracting surfaces there will be two image distances. For differentiating the image distance, let me take V1 for the first refracting surface and V for the final refracting surface. So my idea is here, as soon as if you see about this refracting surface, the ray can come out like this and then it forms a final image over here. So this should be V. If this is going to be V, I have to change this image distance what I have drawn already as V1. So hence my formula I have to change it as N2 by V1 minus N1 by U is equal to N2 minus N1 into 1 by R1 into 1 by R1. because I am going to take here R1, the radius of curvature for the first refracting surface, and this will be the R2, the radius of curvature for the second refracting surface. So now what is the other idea that I am going to implement here? U, the object distance, V1 is the image distance for the first refracting surface. This image distance will be the another object distance, will be this virtual image will act like an object distance for the second refracting surface. So if you check it here, this object distance, the object distance for the second refracting surface is nothing but the image distance, the virtual image distance of the first one. So the idea here is this can be taken as V1 because the object distance, what is the consideration here? The object distance of the first refracting surface will be, right, the object distance of the second refracting surface will be the image distance of the first one. That is the idea that I am going to consider here. So the object distance of the second refracting surface will be the image distance of the first one. That image also, it is a virtual image, right? So that V will be V1. I am taking for the first refracting surface V1, and hence I change the relation. N2 by V1 minus N1 by U is equal to N2 minus N1 into 1 by R1. Now according to this, instead of again deriving by applying the geometrical application, let me consider here the relation, right? So for the second one, now you know that this is your refractive index N2 and this is your N1. So what is your first refracting surface? The equation 1 should be N2 divided by V1 minus N1 divided by U, which is equivalent to N2 minus N1 into 1 by R1. R1 is the radius of curvature for the first refracting surface. This is the equation 1, as you know well. Now I am going to do it for the second one. For the second refracting surface. So this is for the first refracting surface. Both should be highlighted, right? So here the second refracting surface, what are the things that I told? I can change this according to this relation. If I derive it also, I will be getting like that. Here N2, the last part, instead of N2, here the final image is formed at N1. So I can just write it as N1 by, that is image distance, the final image distance is V for the second refracting surface, minus, right, the previous one is N2 by, what is your object distance? V1 is the object distance, V1, which is equivalent to N1 minus N2 into 1 by R2. This is my second consideration. So what I have done here is, first refracting surface I have derived it. For the second refracting surface, instead of deriving it again, I have assumed it. That is the idea I have done. Now what I am going to do here, the equations 1 and 2 must be solved. The equation 1 and 2 must be solved. So if you add 1 and 2 on left hand side and right hand side, you will be getting it as N2 by V1 minus N1 by U, right, plus N1 by V minus N2 by V1. On right hand side, it is nothing but N2 minus N1 into 1 by R1 plus N1 minus N2 into 1 divided by R2, right? So here you can be able to see that this N2 by V1 and N2 by V1 is getting cancelled. So you will be getting it as N1 divided by V minus N1 divided by U. Here if you take N2 minus N1 outside, you will be getting it as 1 by R1, and if you interchange this N1 and N2 in the second one, you will be getting it as minus 1 by R2. So now N1 can be taken outside and can be brought towards here. So 1 by V minus 1 by U, which is equivalent to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2. So this also can be written again like this. N2 by N1 minus 1 into 1 by R1 minus 1 by R2. So your final relation can be written as 1 by V minus 1 by U, which is N2 by N1 is nothing but N21 minus 1 into 1 by R1 minus 1 by R2. This is the relation that I can name it as, say, 3. Now let me assume here as, let the object distance be at infinity, right? Be at infinity. If the object distance is infinity, then 1 by u is nothing but 1 by infinity is equivalent to 0. So, if the object is at infinity, according to the image formation, your image distance will be at the focal length. So, I can write according to the third equation, if I substitute the above, 1 by V is nothing but F. This 1 by U is 0, right? So, need not write this. So, 1 by F is nothing but minus 0, need not write that. And then you can write it as N21 minus 1 into 1 by R1 minus 1 by R2. This is the other relation that I can get it for 4th. This equation 4, this equation is called as Lens-Maker formula. It's called as Lens-Maker formula. And if you compare third and fourth equation, what do you obtain? The left hand side, right hand sides are equal, and if you compare third and equation, the left hand side can be equated. So the left hand side, third and fourth equation, if you compare it, you will get it as 1 by V minus 1 by U, which is equivalent to F, 1 by F. So this equation we call it as thin lens formula. By geometrical application, again we can derive this thin lens formula. So we obtain the Lens-Maker formula by comparing these two, right? So now if you see about these two diagrams here, right? So diagram number 1 and this diagram number 2, right? Together, if you want to see how the refraction obtained, say the image distance of the first one will be the object distance for the second one. So this can be obtained like this, right? So here, if I say that the whole diagram will be, the meeting point will be optic center, this is your pole 1 and this is your pole 2, right? And then you are placing the object like this. You are placing the object like that, and I consider always one along passing through the principal axis, which will suffer no deviation, and the other one is it suffers a deviation since it is falling at certain angle, right? So this is your N1 and this is your N2 and this is your N1. So when it is passing from rarer medium to denser medium, it bends towards the normal. So the normal can be drawn in such a way, you can be able to imagine that it bends towards the normal. So first one, for the first refracting surface, let the image be formed at here. This may be I1. And you have used the other refracting surface to manufacture the lens, convex lens, so that the image distance V, this is your object distance U, and the image distance V1 will be the virtual image. This virtual image will act like an object distance for the second refracting surface. So for that, with the help of the second refracting surface, the final image will be converged here. So this will be the converged. Only if one refracting surface alone is there, right? If only one refracting surface is alone there, then you will be getting the image at I1. Since you have two refracting surface, so this is your another refracting surface, am I right? So this is your another refracting surface. If you have two refracting surface like that, then you can be able to say that due to this second refracting surface, the image is formed at I. In that case, the V1, the image distance of the first refracting surface, will act like a object distance for the second refracting surface. So by this diagram you will be understanding. So what is the thing that we have done? Assuming the first refracting surface, get the generalized formula, and then you can apply the same concept and modify the necessary N1, N2 and N1, and then you can go for the second equation by having the idea of second refracting surface. So both the equations has to be solved, and then you can be able to obtain a relation. We call it as Lens-Maker formula if you assume the object distance be at infinity. This is the generalized formula called as Lens-Maker formula. And if you compare third and fourth equation, we derive the thin lens formula. Immediately go through the content and write a self-test and practice yourself. Do not leave a moment, leave nothing for tomorrow.